Brooke Sinclair, and I work with EnSafe. We're a multifaceted environmental health safety consulting firm based out of the Tennessee area, but have offices across the U.S. And so what I'm going to talk about today are sort of a blueprint for compliance for PCBs. I worked as a consultant that went to a public utility for about 20 years and then came back into consulting just a year and a half, 2 years ago, primarily supporting electric, gas, water, wastewater, and fiber utilities. And so we get lots of questions from our clients, and I thought this would be a good way to kind of talk through just some key things that I'm seeing. The Toxic Substances Control Act is a very detailed regulation, and so we're just going to hit on some key points today as we sort of work our way through PCBs. I'm going to focus on the federal level. There are state requirements as well, too, depending upon your state. So make sure that you're checking with your state legislation as well, too. And, just to kind of further that short disclaimer, every situation is different. And so, since the TSCA rules are very prescriptive and they're very detailed, I would encourage you to give me a call, shoot me an email. I'm happy to answer any questions after the webinar, but it's tough to get into the details when you're dealing with such a prescriptive regulation. So with that, I'll get started. So there are some key things that I wanted to discuss today, 6 points here. The first one is I want to give just an overview of what polychlorinated biphenyls are. Talk a little bit about employee safety and really the hazard communication component of that, because that is a requirement from OSHA, the Occupational Safety and Health Administration, that combines with your Environmental Protection Agency requirements. Talk a little bit about the Toxic Substances Control Act, or TSCA, just an overview, give you a couple of links for some resources. We'll talk a little bit about spill reporting and cleanup, more importantly, audit readiness, and then proactive equipment replacement. So just a quick overview. We've got 6 sections that we're going to work through. We're starting to see a lot of new faces in the PCB management industry. A lot of our tenured folks are retiring out, or we've had shifting and movement within utilities and across utilities. And so I thought I'd take just a couple minutes and kind of go over what PCBs are. I think for the environmental health and safety people on the call, this is some great content that you can pull into your presentations as well, especially for the first 2 sections talking about hazard communication. So what are PCBs? Well, they're this very large group of man-made organic chemicals. They were first synthesized by a German scientist way back in 1881, but it didn't really start to hit the market and get production until about 1929 from a company called Swan Chemical Corp. They were later bought by Monsanto and kind of pulled all the manufacturing into one manufacturer. The thing about PCBs is it's all based on where the chlorine atom is located with your hydrogen. And so the number of chlorine atoms that you have, that's going to determine, and the specific location on that benzene ring, that's going to make the difference of those physical and chemical properties for that particular PCB chemical. Monsanto did stop making PCBs in about 1977, which was a couple years before the actual nationwide ban came into play. So PCBs have properties that really make them desirable for the chemical industry, especially more for like your commercial applications and your industrial applications. They're non-flammable. They're very, very stable, and they don't break down easily. They're very resistant to acids, bases, oxidation, and temperature changes. They're non-conductive, and they have a very high flash point. And so they're great insulating properties for electrical equipment. And PCBs have been used in just a myriad of commercial and industrial products as well. So it kind of became hailed as this miracle discovery. For my EHS people, you might remember asbestos was kind of in the same boat, and we know lots about asbestos, and and how it affects people today. And so I think that's an important thing to always kind of keep in mind when we see these miracle chemicals. So it was really pretty ubiquitous. It was used in lots of different applications. So I mentioned produced domestically from 29 to 1977. There's an estimated 1.2 million tons of PCBs that were produced, and around 40% of those are still said to be used in industry today. And if you just look at this pie chart, you can see PCBs were used in lots of things like paints and rubbers and caulks and motor oil and lubricants, but 60% was used in the transformer and capacitor oil industry. So you might think, well, okay, in the electric industry, where can PCBs be? And the short answer of that is anywhere oil or a tar-like substance could be located, PCBs could be there. So think anything like your transformers, both pole top and pad mount, a breaker, a capacitor, a bushing, even your cable, especially like in network situations, it does have a small amount of oil, and that small amount of oil can have PCBs in it. Just remember, a big component of PCBs is this was considered a miracle chemical, and it was added to oil as an additive. And so companies actually paid extra for this. You may not have even spec'd it as a part of your specifications when you ordered your electrical equipment that was oil filled or tar filled. You just may have gotten some of that as a part of the cross-contamination process from using the same hoses and the same tanks and the same piece of equipment. When they were filling that transformer with PCBs, they just used the same equipment to fill a non-PCB. And so that's how we see a lot of cross-contamination, small amounts of PCBs in different electric oil-filled equipment. So to further that discussion on the HAZCOM piece, since PCBs are considered a hazardous substance for workers, it's important that we do train them on HAZCOM. And that's under the OSHA requirement 29 CFR 1910-1200. And there's really 5 requirements in order to meet the HAZCOM standard requirements. And that's one, you got to tell your workers how to detect and how to respond to a spill. You got to talk to them about the health effects of PCBs, how to protect themselves to avoid exposure, including PPE and what the labels mean. You have to tell them what's in the SDS, their safety data sheet, where to find that information and how to use the SDS, and where to go for more information. So I've got a few slides here that I use in my HAZCOM training for PCBs that I want to just put out there that you can use if it's helpful. So just remember, there are multiple pathways that PCBs can get into our bodies. We can breathe it in, we can eat, in the old days, contaminated food that might have it. We could touch oil or any other substance that has PCBs in it and get that into our system. And then once it's ingested, PCBs absorb through our digestive tracts that go through or it can come through our skin as well. And as those PCB molecules make their way through our blood vessels, they go to that lymphatic system, and that's what's responsible for doing our filtration. So through the lymphatic system, we're able to get some of those smaller PCB molecules filtered out, but the bigger ones, they continue on and they kind of accumulate as well in our fat. And so that can be in our brain, in our liver, it can be in our skin, and it's especially important for our pregnant women that PCBs can accumulate in placentas, the umbilical cord, breast milk, just the whole gambit that you can think in a typical accumulation hazard. And then this results in many times cancer. It could be from a problem with maybe your immune system or neurological as well too. So there's some pretty horrific events that you might have heard about many years ago where large doses, large quantities of PCBs were directly impacting people getting onto food and ingesting it in different countries especially. And these cause some pretty severe and pretty immediate health concerns. Chloracne, which is a pretty terrible situation to have, and then you've got a lot of immediate cancers that were occurring, liver, brain, kidneys, all those functions. And that can still happen, but the reality is today we're pretty aware, and as we kind of worked our way out of using these from a broader sense, mostly what we're seeing is people can touch oil containing PCBs and absorb that into their skin, typically in smaller quantities. They're going to touch their eye, maybe touch their mouth, and that's how they can get it into themselves. We also may see oil splashing, and that can happen from a variety of ways. We still drain transformers, and we still pump them, and we still sample them, and we still clean up spills, and so we can always get splashes as well as skin hazards there as well too. And then certainly if electrical equipment catches on fire, we have some pretty major vapor issues because now we've aerosolized PCBs and put that into the air to bring that into our lungs. But in all cases, the dose makes the poison, and that's an old saying that's going to be true today and true forever. And that's just something that's really important to explain to the worker. There may not be that immediate reaction, but as we're accumulating PCBs in our system, and especially PCBs at higher doses, the more damage that's going to do to their body long term. And I like to always compare it back to asbestos because usually someone will know someone that has had some asbestosis or mesothelioma or some other disease that's been contracted from asbestos. So it's a similar delayed effect that you won't detect until 20, 30 years later. So how does a worker protect themselves? Well, here's some prevention strategies, and I think we need to be pretty direct about this. And the first is skin. Like, we need to be using chemically resistant gloves like nitrile. We need to be using Tyvek suits or some other chemical impervious coverall when we're out in the field and cleaning spills up. We need to use safety glasses and sometimes goggles, depending upon the splash hazard. It's hard when we're on construction sites to wash our hands really well, but we do have water, and so I think the key is covering ourselves with PPE and layers when we can and barriers, but then not touching our face and not eating food unless we've washed our hands thoroughly. And then the last piece of this is when we're in a situation where a transformer could be heated up and we don't know the PCB content, or we do know the PCB content, using a respirator, if we can read that in. And certainly when we're doing spill cleanup, that's a big factor to think about, as PCB oil can be in sediment that can be dust in the air. Well, that's going to have PCB, potentially oil, contaminated with that. So all these things should be a factor depending on what you do at your utility that you need to think about when you're explaining to your workers about how to protect themselves from PCBs. So the next phase of that is, okay, well, what do I do if I get PCBs on me? Well, the first thing is we need to remove and bag. And you know, in my history, I've had to remove boots and clothes and car seats and cabinets and many, many other things. So the more opportunity that we have to touch different substrates, they get cross-contaminated. So it's important to really raise awareness of knowing what's in your transformers and making sure, or other electrical, oil field electrical equipment, and making sure that our employees really take care to not track oil around. From a skin perspective, like many other chemicals, we want to wash with soap and water for at least 15 minutes. Eyes, same thing. We want tepid water, and we want to flush those out for 15 minutes, remove our contact lenses, but that's an organ that we really want to go see a medical doctor from if we do get PCB contaminated oil in our eyes. Inhalation, the first immediate thing is to get to fresh air, but then same thing from an eye perspective, we need to make sure that our employees are seeing a doctor. And then any way that we could possibly ingest it as opposed to inhalation, those are immediate seeing a doctor situation, which could be an OSHA reportable event as well too. So prevention is really the key. That's what we really, really, really want to focus on. At the end of this presentation, I have some links, and you'll see these a safety data sheet that I've pulled and used at other locations. It's just an example. It may not be your specific Aerochlor that you have at your facility, but it's pretty common. There's a couple of common Aerochlors, which is a type of PCB that most electric utilities were involved with. The two pictograms that you see here those are what will be on the SDS. I mean, it's not like we produce this material anymore, so it's not going to be on a bottle, but it'll be in the SDS, and that's something to explain to your employees. This is both a health hazard for them, but it's also an environmental hazard. And so a big component of spill cleanup is making sure we don't allow oil to get to waterways, which also includes storm drains and catch basins and drainage ditches in right-of-ways where a lot of our equipment's going to be located. So when we're discussing this with our workers, it's really key that we not only explain to them the bioaccumulation component for humans, but also for fish and animals as well too, when we have spills or leaks. So how do PCBs enter the environment today in the US? Well, probably the number one is a leak from a PCB containing electrical equipment. We still have equipment out there at this point. If it was made in the late 20s, it could be 70, 80 years old, but older equipment lasted much longer. So we are still seeing PCB equipment out in our distribution systems today. Could be from improper or illegal dumping, and part of that is also when we have a spill that occurs within our system and we're not cleaning it up appropriately. That is another avenue of illegal dumping that can occur. Runoff from wind or rain. So as we see PCB oil-containing PCBs will have leaking on a transformer. You can have rain wash that off, water migrate down, also could have a wind situation, then really just poorly managed waste at our storage sites. And so I mentioned that the PCB rules are very specific. They're very specific on storage for disposal as well as storage for reuse at our transformer shops or in our shop areas of how we can store materials and how we can't. And so we do see, when I'm auditing, I'll see issues with just improper storage, maybe storage outside, free liquids, and those are all things that are not technically allowed when you're looking at the TSCA requirements. So PCBs were so great. What's going on there? Well, once in the environment, they don't break down. That's the beauty of them being so stable. They just really don't break down. And they can stay in the environment for many, many years, and they can cycle through the soil, the air, the water, and you'll start to see that accumulation in roots and leaves and animals and making their way to waterways as well too. And so we need to explain this concept of bioaccumulation up through the food chain as well. So those are some key things, and typically when I'm training this, I will actually pull out the SDS and we'll work through it, because the 16 parts are still a big key of how we need to be training for HAZCOM. Here's a couple links that'll be in the presentation as well that you can use to get to that information. So moving on to Section 3 and talking specifically about the Toxic Substances Control Act, there's really 6 areas that I want to focus on today. And there are a lot. This is typically a 2 to 3 day class that I would give as a part of people that are managing PCBs and responsible for that management in their system. And so we'll talk a little bit about what use authorizations are, what is the assumption rule, nameplate data, the importance of that, and how to use it. PCB storage, we'll just touch on that, a little bit of spill cleanup, and then kind of finish up with waste disposal and how that works. So use authorization, big concept in the TSCA regulations. I'm going to give you not just what's in the rule, but typically what people are doing in utilities that are managing PCBs well. Now this is required. You can use anything that contains PCBs as long as it's what's called totally enclosed. It has to be in a totally enclosed manner. Simplest way to say that is it can't leak. And by can't leak, it means it can't weep, it can't seep, it can't leak, it cannot make its way out of the carcass that it is in. You're not supposed to use PCB containing oil near food or feed locations. And so think about like PCB transformers on a pole that's over a garden. That's not technically allowed by the rules. So anything that's like food for animals, food for people would not be a place where you can store and use a PCB transformer. And then also you have to think about sensitive areas. And so most people have already gone through and said, show me all pasture land, show me all feed areas, show me all food areas, and then also looked at their GIS along creeks, especially blue line streams, and making sure that all their transformers with PCBs in them have been removed, because those would be considered sensitive areas. Another type of sensitive area would be like a wetland. Others would be things like daycare and daycare facilities, or maybe assisted living facilities. So think broader when you're thinking about sensitive areas. I think of it more like risk management in addition to just a strict term of sensitive areas. If I have a pad mount transformer in the parking lot of Walmart where I know the traffic is high, people are there, and the potential if there's a leak of what we would have to clean up as a utility and how we would have to interact with the public, those would be areas that if I've not spent the time to go through my system and make sure that those have been removed, that would be a great opportunity for a double check. And then anything that's 500 parts per million would need to be registered. So that's a typo there. That should be 500 parts per million. So let's talk about some key terms. So there's really 4 categories of PCBs that are, some of which are regulated by TSCA, some of which are not. And so the first is obviously oil-free. I see that also sometimes as non-PCB, but there's actually a difference. That means that it's less than 2 parts per million of PCBs in that oil, essentially meaning it's PCB-free. Non-PCBs is really that 2 to 49 parts per million PCBs, because that is technically not regulated by TSCA, but I will tell you, I've taken samples before. The first one comes back at 45 parts per million, and the second comes back at 52 parts per million. So be aware that technically, from a TSCA perspective, requirements kick in. Most requirements kick in at 50 parts per million or greater. However, there are RIPA requirements for waste that has less than 50 part per million for disposal. So be aware of that. The main group of contaminants that we're talking about, and what you'll typically see at your utilities, is that 50 to 499 part per million PCBs. So those are what's called PCB contaminated. And then something that's PCB would be 500 parts per million or greater. All of that matters because regulations are applicable depending upon the level of PCB. And typically, that is how our labeling will occur as well too. So if you're new to the industry and you're seeing green labels and blue labels and red labels and yellow labels, those all indicate different PCB content. And it's important that our staff knows the difference between PCB-free and even non-PCB versus PCB contaminated and truly PCB 500 parts per million or greater transformers. So the assumption rule is a rule that says, hey, technically there is no requirement to test your equipment. If it does not have no PCBs on the nameplate, which I'll talk about that in a second, from your manufacturer, you technically do not have to sample or know what your content is. But you've got some options if you choose not to sample. And there are different assumptions that you have to make depending upon the type of equipment that you have at your facility. So if you have mineral oiled electrical equipment that was manufactured before July 2nd, 1979, you don't have any, PCB data, you have to assume that it's PCB contaminated. And remember, that's 50 to 499. If you have non-mineral oil, meaning tar-filled electrical equipment with 3 pounds of fluid or more, which is hard to know. So rule of thumb, if you think it has tar in it and it was manufactured before July 2nd, 1979, and you don't have any PCB data, meaning you've not tested it, you're going to assume it's PCB, which is 500 parts or greater. And then you have the third option. If you've got a dry type piece of equipment, meaning there's no oil in it, no tar, and manufactured, or if it's manufactured after July 2nd, 1979, you can assume that it has no PCBs in it, unless you have something that would make you think to the contrary. So the assumption rule is a big component of the TSCA rules and what we've been working under as an industry for quite some time. Most utilities did not go out and proactively sample unless they were planning to do removals. And so there were issues with sampling where transformers were tapped, shavings fell in transformers from the tapping process to just get the sample. And so we were seeing a lot of failures afterwards. So many utilities decided either not to tap the transformer, just go with the assumption rule, and then work through replacement as part of normal asset management. This is a big key. Or many utilities proactively went out, sampled, replaced, or assumed and replaced based upon their previous data that they had as well too. So lots of different options, but the assumption rule is something clearly in the TSCA regulations that gives you direction if you do not have PCB data either on a nameplate or from testing. So I mentioned a nameplate. Nameplate's really, really key. It comes directly from the manufacturer, and it will say something like contains no PCBs, or less than 2 parts per million PCBs, or less than 1 part per million PCB. So the nameplate that you see on the left, that is different than a label. So, many utilities require that their manufacturers put their labels on them, whether it's their transformer numbers or equipment numbers, but they will also many times require them to put a blue label like this on their equipment as well too, so that the crews can see it from a long distance away. So it's key that when you see a label, if a label's been added, make sure that it is qualified by the content. So again, less than 2 PCB free versus less than 50, which is non-PCB. It's really important to understand and know the labels in your system and train your staff on that as well too, because reading the fine print will make a difference. Labels were not standardized other than the PCB mark, which is a yellow label. So the EPA actually has a guidance document, since we've had nameplates for so long now, that really kind of walks you through how to use your serial number, because in many cases, in almost every case, your serial number will help you determine if it has PCB content in it without even having to take a sample. And so just a couple of examples here, like there were some locations and manufacturers that never used PCBs at a specific plant. And so if that's in your serial number, then you know that that is not going to have PCB. So for instance, I'll just use Coleman. It's a very common brand that's out there, pole top transformer. In this guidance document, which is linked at the end of this presentation, it clearly states that PCBs were never used at their Kentucky and California facilities, and that they discontinued the use of PCBs at their Crystal Springs facilities in 1965. So if you look at the nameplate and you use that document, you can see some qualifiers here. So like KU means it's Coleman, a 4 means it was at the Kentucky facility, and the manufacture date is at the very end, and that's an 01. So obviously it's later than PCBs were, after PCBs were banned, and so should not have PCBs in it. I qualify everything by saying that you also have to understand the practices at your facility. Some utilities had a practice of reusing transformers, reusing oil, making repairs themselves. And so the nameplate is only as good as your knowledge of your maintenance and repair practices at your utility. So just be aware of that. You might see some other labels as well too. I mentioned the different colors. This is just one example from a utility that I work with. doing some auditing and helping them keep their PCB management process going strong. And I've seen different colors and different styles. But normally this green typically means 2 to 49. Blue typically means 50 to 499, and then you'll see 500 parts or greater. That yellow label is actually the PCB large mark, and it is required to be used exactly as is for anything that's 500 parts per million or greater. So if you see those labels, that's based on sample data, and that is how utilities know what to put on their transformers. So the big question is always, do I sample or not? I've worked with a couple utilities that have worked through some sampling programs, and the utility I worked for as well, we went through a pretty robust program as well too. And part of that, to make sure that you're sampling correctly and that you're pulling into your sampling group the right types of equipment and as well as age. Think about some of these things. One, how much old, meaning pre-1980 equipment do I have? If I can pull my GIS data and I still have 10 units out there, I'm probably not going to spend the time to sample them. I'm probably going to look at their performance. I'm going to look at when's their end of useful life anyway, and just go through the process of replacement. How accurate is your asset data? When I first started working in PCBs, I found out pretty early that our records, and when I benchmarked with other utilities, their records weren't that great. The difference between the install date, meaning the day that my crew installed that piece of equipment versus the date it was manufactured in my electronic system, were not typically accurate. And they flipped back and forth. It depends on who put the data in. So we had to put some buffers. When we started our PCB proactive removal program, we didn't start with anything 1977. We put it all the way back to 1980. So we sampled everything and put eyes on everything that was 1980 or earlier. Nameplate helped us in many cases, but we wanted to make sure that we didn't have an issue with install versus manufacture. We did not have a great practice of turning over transformers sometimes in our career, just based on how big they are and having to rotate those through our fleet, so to speak. And so a transformer could sit at the manufacturer 20 years ago for a year, and then it could sit in my back toll yard for for a year, and now it's 2 years older than what I thought it was. And so just keep that buffer in mind depending upon your practices. Do you have any specialty equipment like network? I mentioned the great properties that PCBs have, and those type of network equipment and in special locations, buildings, those are where you might have spent more money to get PCBs in your oil. So you definitely want to target those areas as well. And then, did you restrict your purchasing practices and your specs, or was it pretty much you just kind of got what you got? Because the more restrictive you were, the more likely that you did not get PCBs in your system. And I think more like your substation equipment than I would say a smaller pole top pad mount type transformer. And that would help you make some risk-based decisions as well too. Did you have a practice of removing oil and doing repairs on site? Did you retrofill your equipment? Did you buy any used equipment? And then just really how effective were your practices to keep your oil separate? So oil containing PCBs versus PCB-free oil. If you did any of those practices and added to your equipment, kind of topping off the oil, that's something that happened in the past as well too. Now your field staff, they're not going to know to give you this information. You really have to kind of dig for it, and they'll have to remember, because this is going back quite a few years now to be able to get some good answers on that information. So once a PCB article, so that's a term in the in 40 CFR 761 that basically means any kind of electrical equipment, just a generic term, transformers, switches, voltage regulators, capacitors, whatever. Those are all articles. You have some options for how you store them. If you're going to store them for reuse versus store them for disposal. So if you're planning to reuse that piece of equipment, which unless it's a very special piece of equipment, I would typically recommend not to do that. But there are some substation level and network level equipment that's very specific and costly, and you might need a spare. That's where I see a lot of this coming in for spares. You've got to do some things. You can keep it for 5 years without doing anything extra, but you got to make sure that there are no free liquids, meaning no oil is leaking out of that transformer or piece of equipment, that article. It's got to be labeled. It's got to have the PCB content on it. And you've also got to determine, like, where's the future use of this? So if you think about why EPA did that, they didn't just want electrical equipment that contains PCBs sitting around indefinitely. If it doesn't have a use, then it needs to get moved for disposal. And there are inspection requirements as well, too. And the need PCB transformer that's 500 parts per million or greater has to be registered through EPA. And you've got 30 days to do that. So just keep that in mind. Moving to disposal. So if you are storing for disposal, you've taken your sample, you're waiting for your disposal company to come pick it up. There's a very specific setup that's required for short-term or what's called temporary, where you can store something for 30 days, versus long-term, which is 31 days and more, of how you have to actually set up your PCB processing area. So consider that as well, too. And there's very specific requirements, 6-inch curbing, specific type of concrete, or typically people use metal trays to do that. Volumes matter. So there's some very specific requirements there. But without a doubt, no free liquids. So whether you're storing for reuse or you're storing for disposal, you need to be inspecting those and making sure that nothing leaks. And if it leaks, it should be cleaned up immediately, and it should be documented as well, too. And that storage for disposal has some very specific 30-day inspections. So not monthly, but 30-day inspections. And then once it's in that storage for disposal area, it has to be packaged as though it's going for DOT, Department of Transportation, shipment. So it should be ready to be shipped when it moves into that area. So talk a little bit about spill cleanup and disposal options. Well, there's actually 4 different ways that you can clean up, and these are very prescriptive in the regulations as well, too. You can use what's called the cleanup policy, and there's recently been some changes to that. In the past, that was a great way to go if you had a smaller spill, lower concentration, so that you could not notify EPA and go through the paperwork. You just had to do it in a very prescriptive manner, and there was no notification. Today, there's actual notifications that have to be made. A self-implementing cleanup and disposal, then there's a performance-based cleanup and disposal, and then there's a risk-based cleanup and disposal. So all of these have their own very specific requirements, very specific reporting, and then there are approvals that have to be requested from EPA to go through this process. So if you are cleaning up, if you do have PCB and have cleanup that you have to do, it's important that you have a really specific procedure so that your crews, your substation technicians, whoever's doing that cleanup, your third party, performs that cleanup appropriately. And depending upon the policy that you're going to use or the cleanup method you're going to use, there are several factors. One, extent of the cleanup. How big is it? Is it a couple shovels full underneath the pole top transformer? Or do we have a larger spill that we didn't detect for quite some time? What available records do you have? Do you have test data? Are you using the manufacturer's nameplate? Do you know without a doubt that no PCB oil was introduced into that transformer if you are relying upon that nameplate? Don't forget the reporting requirements. EPA, again, made some changes that were effective in February. There's a great presentation that EPA did that I've posted at the end of this presentation as well, too, in a link that you can get back to that shows what those changes were. But your states also could very easily have reporting requirements as well, too. And the last piece, think about your legal risk. Again, if it's a few shovels underneath a transformer, that's one thing. But I've cleaned up multi-state cleanup events where PCB contaminated oil made its way onto um, materials that were taken to multiple places. And the extent of cross contamination in EPA's mind is a very, very low threshold, and you will replace many things, materials, flooring, cabinets, whatever, cars that could be cross contaminated, and I say could be cross contaminated with PCBs. So you definitely want to consult an attorney that's familiar with TSCA, not just an attorney that's familiar with environmental, because the TSCA rules are very prescriptive. Think about that long-term liability, because you are always going to be a responsible party. So this is not a situation where you can just turn it over to an emergency response contractor and just walk away from that. You really need to know what they're doing, and they need to follow your procedure or give you a procedure that's approved from the point of cleanup to disposal, and so that you get that record back from the disposal company. And then, don't hesitate to engage in a consultant, somebody like an EnSafe that you can ask questions to, or that can ask questions for you on behalf of a utility, maybe back to EPA, so that you can remain anonymous. So those are all some things to think about if you're cleaning up spills that have PCB containing oil or tar in them. So there are also some waste disposal requirements that I wanted you to think about as well too. You can have oil-filled or tar-filled equipment that are possible waste materials. You can have sampling materials, tools, water, spoils, which I would call rock, dirt, debris that you've dug up. The possible routes for disposal are going to be incineration or land disposal, depending upon the PCB content and your permit that you have to dispose of those. And yes, anything more 50 parts per million or more is going to go under the TSCA rules, but RCRA also comes into play when we're talking about less than 50 parts per million PCBs. So that's another item that people seem to forget. So when I'm doing oil spill response or PCB cleanup training for line workers, substation crews, troublemen, they're the first responders of this. And so here's some slides that I just kind of go through when I'm talking to them. And the first one is, there's really three primary roles when we're talking about cleanup and management. First one is line workers. Second is whoever processes this equipment. And in many cases, it's a substation group in most of the utilities that I've seen. And then you have record keepers. Those record keepers could be EHS staff, or they could be your substation supervisor as well too. It's pretty common. So line workers, they really have two things that I need them to do. And the first one is they need to communicate. If you see a transformer, a bush, if you see any electrical equipment that's leaking, we need them to know or understand the potential PCB content, and they need to communicate that back to whoever is responsible for oil spill response. Those are their two main focuses. And we talked to them about there is, the difference in a leak and a spill, but really not to TSCA. But the way we look at it is we would call it a leak when PCB fluid is on the exterior of the equipment. So it's on it, but it hasn't technically made its way off. And that's what we would call a spill. And that's where you're going to have PCB contaminated oil that's impacting land, water, any kind of area where the public can be exposed. So those two definitions are in there in the rules, but there's still cleanup is required for both of those cases. I hear the term weep, seep. Maybe there's just a little bit of residue that's come out of a gasket. That still even has to be cleaned up as well too. So when we're talking to our crews, we say, well, they're always asking, well, what do I do if oil has leaked but hasn't migrated off the equipment? Well, the first thing I tell them is avoid contact with the oil. That's number one. Number two, try to determine the PCB content. Look at the label if your utility uses labels, or look at the nameplate if at all possible. Put on their PPE, chemical gloves, suit, booties, and they do have Tyvek, and that's what we mean by a chemical suit, and nitrile gloves, not their rubber goods, and then kind of get their spill equipment ready. So most utilities that still have PCBs in their system, they have transformer bags on their vehicle, they have kitty litter, they have some type of absorbent, some socks and booms to be ready to do some initial containment. That's my main focus for them. Disconnect the equipment, remove it from the base, and then place the equipment in the truck securely to ensure that we don't have a leak, because we want to avoid increasing a leak into a spill. And if we're not strapping those down and putting them in transformer bags, we start jostling that equipment around, gaskets move, and oil starts to leak out. So it's really key that you think about using transformer bags for any kind of suspect equipment. Make sure the lid's secure and that they strap it down and make it secure for transport. So for an equipment processor, they really have 5 main areas that I see them perform. And the first is they conduct the PCB sampling. They'll also manage the storage areas and conduct the inspections. They will conduct or manage, if they use a third party, spill cleanup and reporting. And then they'll also manage the disposal activities. So there's manifest involved, there's signatures involved, pickup, and then you have to get the certificate of disposal back from your certification company. So those are typically what we see equipment processors, and again, that's usually the substation groups within most utilities that I work with. So, sampling for PCBs, I get questions, well, should we sample it as the utility or should we just send it on to the disposal company? And I've even had these discussions with one of the larger disposal companies, and I think we're definitely in agreement. If you can sample at the utility, that is the best approach. You bring it in at your receiving area, put on your PPE, treat all that sampling material as PCB contaminated because you don't know. And so that's a disposal track that we want to make sure that we have in place. And then use a chain of custody to track your samples and keep a copy so that you can go back and check the results. Labs aren't perfect and they could miss a sample. And so you want to make sure that everything matches up with your sample number on your bottle to the results that they have. And if you see anything that doesn't look correct, that's a great opportunity to call your lab immediately. If you do allow your disposal company to sample, that's okay, and that's perfectly legal to do that. You'll just ship everything as assumed contaminated unless it's tar filled. It's a little harder to send for repairs because if you're assuming that transformer is contaminated, they sample it, it's not, and maybe all your repairs go to a different facility. Now you have to work through that process. So I would think about the flow of that as I'm determining who's going to conduct samples for PCBs when they do come in for processing, not in a proactive manner. And then just another thing that I see issues with in the field for equipment processors, make sure that your inspections are 30 days or less, not monthly, because that will actually be tracked. And anytime that they're encountering any oil that's outside of that piece of equipment, they make a spill report. And it's not lengthy when you're in your process area. It has to have the inspector, so who found it, what the date was, what time the leak was found, and the description of the leak with the cleanup results. It's critical to do that immediately. That's why they want the date and the time, because EPA wants to be able, when they're auditing, to go back and track that. So there's nothing that says you have to inspect every day, but I think the key is that you do have a good process in place where someone is walking through that area fairly regularly to bring equipment in from your processing or receiving area, get it into storage for disposal, and making sure that those inspections are happening frequently so that you can prove that you're managing your waste effectively. So record keepers have 5 main responsibilities as well too. And again, this can be an EHS professional because they're not hands-in processing. I see a lot of record keepers that are EHS professionals, but I also see a lot of substation supervisors in that role as well too. And their 5 main items is conducting inspections as well too. So it's important that there's some oversight, the management component of this. Number 2, there are making sure spill reports are complete, and spill reports can be in your shop area, like I just mentioned, or spill reporting and cleanup also occurs out into your distribution system, and there's much more data that needs to be collected there. So all that data collection is a huge component for spills for record keepers. The sample data, putting that in something that you can track to the equipment number. And then there's an annual log, depending upon the amount of PCBs that you process each year, that has to be kept and even submitted to EPA potentially as well too. And then tracking all your disposal activities and manifests and those certificates of disposal coming back in. Because your annual report that's due in July, you want all those records to be together for audit readiness, which is what I'll talk about next. So just a couple key things to make sure that you're ready for an audit. And the first one that I always recommend is having a written plan or a management plan. I'll hear people use that term as well too. The 2 pieces of that, research and write it. You really got to understand your current PCB status, what you have, what you don't have. If you can't easily provide those answers when you get that unscheduled inspection from EPA, if you're a facility that has an EPA ID number for PCBs, it starts off on the wrong foot. So understand current PCB status and what you did at your utility, and write that down. I mean, write that in a legally defensible way, but write down so that you know and can easily, or anyone could regurgitate, here's what we did in our practices in our utility. You're going to have to really dig into 40 CFR 761 and your state requirements based on what you currently do today. And again, remember, the PCB cleanup and disposal program was just updated back and was effective in February. So go back and look at those requirements as well too. So then just write it down, summarize the applicable requirements, those that are applicable to your utility, not just a summary of this gargantuan regulation. Know what you do and tie that back to the parts of the regulation that are applicable to you. Define roles and responsibilities. I mean, I've given you the 3 main roles that I see in managing PCBs, but who does what? Who does the training? Who keeps the records? Who's responsible for what inspection? Who's the decision maker on whether a transformer gets stored for reuse or disposal? Is that an engineering group that comes into play? Because there are a lot of departments that could have their hands in PCB management activities. And then develop procedures so that each role knows what they're supposed to do. Develop forms as needed so that they have some place to write down their inspection data, for instance, and then develop training. And I highly recommend an annual type of oil spill response and couple that with a record keeping process as well too, just ahead of when your annual report is due. So then implement it. And there's 6 steps to implementing the program from what I will typically recommend or see within utilities. 1, annual training. 2, required inspections. 3, clean up spills immediately. Keep your records up to date, meaning don't just let all those certificates of disposal pile up. At least look at those monthly, every other month, depending upon how often you get your shipments in, because it can take time. It takes months to get all your records together. And something can happen, and if your PCB record keeper is out, you don't want to have to pull all that together and make a lot of guesses and assumptions. I highly recommend auditing your facilities and your processes as well too, to make sure that they still work and things are still happening. We are seeing, as I said, retirements happen, so people don't understand exactly what they're supposed to be doing and why they're doing it. So we see a lot of sort of scope creep and not as diligent as we were in the past of managing PCBs. And then, consider having a third party resource like an emergency response contractor under contract to clean up spills that are knowledgeable in PCB cleaning. So kind of wrapping up with our last section, and this is something that really want you to consider if you still have PCBs in your system, and that's how to proactively phase out equipment that contains PCBs. There is a way to couple that in a risk-based approach with your already implemented asset management systems. We do pole replacement. We do replacements of these. We just don't always marry all of this up. PCBs may not always be a factor in what you're considering as a part of your replacement and programs like poles and other equipment, and how you kind of rank those. So, when I think about a risk-based approach and how I normally tackle this is, one, what do we know about our PCB content? Try to get that as much as possible. Nameplate, make some assumptions, pull your test data in. If you have a robust GIS, that's going to be your friend in pulling this data. Start with anything that's high concentration, 500 parts per million or greater. That should be your first focus, because those are technically supposed to be registered if it's a transformer, and that puts you in an EPA database. And so I think the big key is getting rid of anything 500 parts per million or greater. The next would be focusing on anything that has had leaks or weeps. And I always think about my sister units as well too. So if I have equipment that I've had trouble with, I go and try to find those sister units as well too, which you can tell by your company numbers, usually what was ordered at the same time from the same manufacturer. And so that's something to think about, because in order to use PCBs, they can't leak. So target those next. Take a double check and make sure that everything in those sensitive or high risk areas have been addressed. Things have grown up around us, and so a piece of equipment that may have been out in your system 20 years ago or 10 years ago when you checked on it, it may have a Walmart beside it today. And so go back and look at those sensitive or high risk areas. A wetland can actually be created in 5 years, so things can change even in our vegetated areas as well too. And then I just start with the highest and work my way down to the lowest concentration units, and just work those in chunks and work those in areas geographically. And then at the end, I would look at my 2 to 49 part per million equipment, where they are, how many pieces do I have, and how quickly can I work those out of the system as well too. Because as I mentioned, the first time I sampled, it may have been 45 parts per million, but if I have to sample it again, it could be 52, 53. And so I would give myself a buffer at a minimum for that. So know your PCB content. I mentioned that we queried, and what I recommend is giving yourself a buffer if you don't know the difference between your install and your manufacture date. So think about that as you're talking to your staff. And then I always spot check as well too. If I went with manufacturer date, does that actually match nameplate? So do a little spot checking, and then understand that repair history that we talked about earlier. If you did a lot of repairs, if you replaced oil, then you've got to move to the sample as a component as well too. So I mentioned using that EPA guideline document that's linked in this next slide, and that'll help you with serial numbers. Use that assumption rule, use their previous data to know the content, and then just be skeptical. You might think that you can just make an assumption and these are all PCB free, but when they get to the disposal company, they're gonna sample it. And so I've had transformers sent back to me in the past where we made some assumptions that were not accurate. And that is a process to get through as well too. So here are some helpful links of just 3 of the documents. And certainly if you have any questions or comments, feel free to reply, let me know, and send me an email. My QR code is here. You can, on the screen, flash that in and it will come to me, and I'm happy to answer any questions. Thanks, and have a great day.